3 minutes, Donnie. Do you want your phone? Okay. Yeah. Yeah. 3 minutes. I'm trying. 2 minutes. Hey, everybody. Scott Stevens here. We're going on live once again, and looks like Stella's not in her bed today. She's actually sequestered upstairs just in case. Gotta love our dogs, don't we, all? Got a few things to look at today. Let's just pop on over to Facebook because one of the first things I do in the morning is look at the satellite imagery. It kind of gives you a quick overview of what's going on. And because I'm in the States, it tends to be largely, state centric. It's curious how long it took me to quit looking at Idaho closely when I moved to Colorado. And then to quit looking at Colorado once I spent a year and a half in Puerto Rico. It's odd how where your location is, you really tend to kind of put the rest of it out of your mind. And when you're and when you're forecasting, hey, how about a little audio? That would probably yeah, that's a whole lot better. All right. So what we're looking at is how we tend to get really location centric when we do weather, when we look at news, when we talk to folk, we end up really location centric. And so I was just saying, when I moved to Puerto Rico, I was amazed how quickly I quit looking at the Mountain West, either Idaho or Colorado, or just the whole region, because I was kind of rabid in archiving satellite and radar imagery. And once I left, I just kind of quit looking at it. I was more concerned with where I was and where the weather and what weather was impacting me. I became much more fascinated in, and in a way, it only makes sense. So let's pop over here and take a look at what I posted on Facebook about 2 hours ago. And what I noticed was that there was an event that was happening. And if you've looked through this, we'll begin to see it. And at a quick glance, you're going to be looking at Florida. Oh, here we are. Let's just scroll this on back. You're either going to be looking at Florida, and in fact, I'm going to go one better. Let's just go to the absolute raw picture that I uploaded to Facebook because I kind of tend to be a freak for high resolution. So what I was looking at was what will likely be Arthur down off the Straits of Florida and the remnants of big thunderstorms we were looking last night just now into the Gulf Coast. But if we kind of rock this back and forth, it was eastern Kansas. It was this area and this almost fishbone where there was like the edges of ribs coming off this line of thunderstorms. And straight up, that's not natural. And I'll animate this and just play the whole animation. And you could see how these cuts were really tearing at this line of thunderstorms. And then I'm going to stop it right here. And there were scallops, straight up scallops, circles that were pushing through this line of storm. And there was at least 1, 2, 3, 4, 5 of these events, all with the same geometry, tearing into this line of storms, which could have brought some beneficial rains to eastern Kansas this morning. And since I went to school at KU in Lawrence, and then my first on-air TV job was in Topeka, this is an area that catches my eye now and again, and still have friends in the area. But it was this action, how it's so symmetrical, so organized, that I'm like, there's totally something wrong with it. So let's come over here at radar, and you can see how these impulses, plural, just tore at that opportunity to get rain in here. So my conclusion is that we're likely to begin to see some kind of drying event take place. This is a spot, a location where there really is no drought right now. And if we come over here, because we got the new drought report out today, that much of eastern Kansas and western Missouri in great shape. What I'm going to anticipate as a forecaster, as someone who sees trends and then likes to apply them to what may come, is that in the coming weeks, we will see this drought that is now becoming more and more entrenched across the high plains of Colorado extend into eastern Kansas, Missouri, and maybe points out farther to the east. All right, so that's what I was looking at. I'll pop over here, get down to some comments, and Mike Oliger dropped in this link, and I brought this up, and he was talking about what was it, Mike? RF spikes, that kind of thing, RF spikes. So what we're looking at are what we're seeing also off the coast of California are these spikes. Now these were something, and we've gotten one here off the Topeka radar as well, where there's got to be something in the atmosphere that is resonating it to the point where the water molecules, which the radars are tuned to see, are reflecting back to the radar receiving station, to the transmitter and the receiver, because they're in the same location. The radar pulses, waits for a second, listens for the return, digests the return, and then pulses once again. And you can even have dual bands where you have different frequencies pulsing off at the same time. And so you can get a different orientation or polarization off the water molecule. But what we're seeing are highly reflective pulses. And this activity has had my attention for years as I've watched this whole geoengineering scenario literally kind of unfold. All right, back to temperatures. Across Texas, 90s, very common once again today, even at this late hour, from the Rio Grande Valley on up to the Red River Valley. This is where the storms had cooled Texas yesterday. Beginning to develop temporarily into Southern California. It's much, much warmer in the Mountain West, where we've got largely 50s, a few 60s in some of the warmer locations, and then the 70s trying to bust back into the Great Lakes states. But just on the western fringes, and New England finally recovering with some more moderate May-like weather off to the east. A couple of weather highlights. These are just things that I have favorited on my Twitter feed. At least 4 grass fires kept firefighters in Fresno, California busy last night or Tuesday night and Wednesday morning, because since today's Thursday, dry and windy weather helped to fan the flames. This is just May. And because they had such a dry early spring, their vegetation quit growing and is now browned out terribly early. So this is going to be a continued risk as we move through fall. GEF ensembles, which means probably 20 plus models, are all converging on the solution of this tropical storm, which likely will be named Arthur, traversing or originating across Cuba and then across the Bahamas. Now, the Bahamas dealt with Dorian not that long ago, but its path likely to be out to sea. So the risk of it moving inland is weak. Only a few of the models draw that into the Carolina Cape and then inland, but that likely to be the outlier. And as we mentioned yesterday, Vongfong, the typhoon, you can see the very well developed eye right in there as it begins to make landfall, or as it did already make landfall, since this tweet is now some 15 hours old. Also, what is a strong convectively coupled Kelvin wave crossing the Bay of Bengal and out into the Indian Ocean usually and ripely sets up a nice stage for further tropical development. So we'll look for that development off here soon. And I love Momona's clouds. This time lapse outside of Russia. And as these thunderstorms roll on by, you can begin to see the turbulence being brought down to the surface. And sometimes this turbulence in highly engineered events just carries the moisture almost violently all the way down to the ground. So time lapse is a wonderful, wonderful tool and something that I have used extensively over the years as I kind of how shall I say it, dipped my toes into this field. There's still some things going on in Kansas. Here's where we looked at today with that engineered event, and I want to kind of back off the showers and cool weather out west, a little tropical moisture coming into the desert southwest to kind of re-engage or start early their season. But I want to look at these waves, these unusual waves moving counter to what would be a southerly flow. You can see that the cumulus heading north through central Kansas. These are waves, and their source is easy to dismiss, or their reasons for existing are easy to dismiss. But these, I believe, are key, absolutely key, when you're in the process of engineering weather events, is to watch these waves where they show up on the surface as surface clouds in the mid levels of the atmosphere. And as you get up into the cirrus level where the jets travel, those contrails are absolutely just utterly thrilled to watch and measure these waves. And more so when they begin to counter each other, when you have one set of waves interacting another, because waves always have this way of how do we want to say? I'm going to come back here so I can do this a little of interacting. You can have waves that one is say faced this way and one faced this way, and they tend to wash each other out. But sometimes they collapse, or they come together and then they accentuate. Or if one is say flipped inverted, they come and then there's flat. There's no interaction whatsoever. But that is the science of how we tear apart storms, build storms, but we tend to engineer the weather. We make a storm come in, we can accentuate its presence. The water's already there, the cool air is aloft, the heating's coming in at the surface. Is what can these waves do to make the weather more severe or rip it to pieces? And it really is kind of fascinating. I'm going to bring another image over here. These are just some plain clouds. They look like plain clouds, but what's curious is the tops of clouds are more normal like this. When you see them go fuzzy or hairy, or I had one meteorologist tell me they were just iced out. Well, what caused the icing? What introduced the particulates, the condensation nuclei into those clouds to cause them to ice out? What was that catalyst? And so those kind of clouds are something that I watch very closely. And when I see these kind of clouds, I almost have no expectation get rainfall out of them, no matter how strong the storm, no matter how bullseye of an event the models are predicting. If the model's saying 90% of a chance of rain, and if I look outside and I see clouds that look like this, it ain't going to happen. Somebody else has overwritten what Mother Nature had planned for the area, and their agenda now rules. And that's the kind of fact that I had to accept, when I had a responsibility to forecast, is that when I see these clues in the clouds, I have to change my forecast. Otherwise, I'm out there the next day, eating crow and saying, trying to explain why the forecast that I had presented did not come to pass. That I was not allowed on the air to talk about these things. So I had to be very, very careful and dance around these topics in ways that I wouldn't have otherwise. All right, here's what's happening to the radar stateside. Let's come up here where we have actually a tornado warning. That's what the red is for, just north of Peoria, Illinois, off to the north and east. So we've got this line of storms that yesterday was Texas, western Kansas, and so forth, has now worked its way off to the east. So folks in eastern Iowa kind of under the gun now with numerous storms still developing in Kansas, Salina, Topeka, probably very close to St. Joseph, Missouri, and then into Iowa. We'll go off to the south, see if we can't catch some of those. New Orleans area where they've been kind of dry. I did do that, didn't I? I did do that. All right, here we are. So southern Louisiana, it's been dry down there. So these rains, even though the Mississippi is close to record highs, it's come down a bit because we've had some drier weather. We're just going to put a little more water in there just because, well, somebody wants to. Radar or where we've got the lightning going on. Again, just with those areas of thunderstorms that we've highlighted, some stray storms that developed in the instability of this kind of larger event out here in the western states. We'll see what this happens forecast wise as we go to the Weather Prediction Center, the WPC. It used to be called the Hydro Meteorological Prediction Center, the HPC, but they've changed the name, and I can agree with it. It kind of fits better. But all the green, so there's a lot of showers anticipated across the states, and still some snows or the risk of some cooler weather as we move into the higher elevations of Idaho and Montana, even into northern Colorado, say west of, say, Fort Collins, the Boulder area, though that snow elevation is still 8, 9, 10,000 feet. So those folks that like to hike up high, and severe storms possible with the heavy rain and flash flooding hashtagged or hashed in red for still the remainder of today. The risk resets itself back along the dry line in western Texas. We're watching the potentiality of Arthur showing up. And then on day 3, that low begins to come together. They're not quite ready to commit to a name just yet, but I have no problem going out of the limb. That thing will be named. It will happen. So let's look at the risk of hot or cold weather. Where might we see record highs the next couple of days through Thursday, the 14th? And the Weather Service, now that we've got the internet and there's so many computers, databases are available. They can be scanned and plotted against current conditions. It's really kind of exciting how weather has been computerized for the planet. And so it really lays open historical weather, and you could use it in real time. And this stuff simply wasn't available, when I was on the air 15 years ago. So we get to play with it in today's day and age. So what this is the NDFC or NDFD's forecast, where we anticipate where we could see some near record highs. So GJT right over here, 90 degrees, Grand Junction, Colorado, 81, Alamosa, Colorado, down in the lower San Luis Valley, and then Montgomery, Tallahassee, and Atlanta approaching record high temperatures as we move towards the weekend. Alamosa, Colorado, the only one even close on Monday at 84 degrees. And these are likely model generated. We've got probably some manual input, but they really are kind of hands off and let the computers do the bulk of the forecasting. And that, I'm telling you, is a far, far cry from where it was 20 years ago, where, we paid men, we paid them for their expertise, and we've gotten so hands off. We don't even let humans do the observing of the skies anymore. That is all done by the automatic ASOS, automatic surface observing system. That's all computerized now. And in my eyes, when I saw that happening in the 80s, instantly, Phoenix, Tucson, Scottsdale, and some of those other southern Arizona locations where they were first implemented came out with record high after record high after record high. So there was something that was introduced when we automated the weather observing system in the States first, and then it went global. There was something that changed in the late 80s when we took the human being out of the system and we began putting up these weather stations in places that were not grassy, that were not more representative of a natural environment, but we started sticking them near cement, near buildings, near air conditioning vents. We really, really began to bias our basic data observations to the warm side with this program that began in the late 1980s. And that was also coincided very closely with the beginning of the global warming agenda. So there is a cause and effect with that. And it's interesting because we can go back and look at some of these very long time stations that have 110 years worth of record, and they're almost flat and have shown no warming since the 80s. A lot of this data that's coming in that is showing us and telling us over and over and over again that we've got this warming planet are weather stations that are sitting on top of buildings. They're sitting on next to cement pads. It's bad data in, bad data out. And in meteorology and computer models, it's garbage in, garbage out. And in my opinion, there is a lot of garbage going into the computer models. And that's something that if we're going to really honestly look at where our climate is going and where we are as a planet within these larger cycles that are inevitable that we live within, you've really got to look at how clean and how pure our data is to even figure out where the baseline is. And that doesn't even consider the impacts that geoengineering may be having on, and I leave that with a big white maybe, maybe having on temperature data. So that's something we absolutely have to consider. So just some of the weather highlights. Looking at the stormy weather in the plains, we hit that the flooding that's happening in southeast Texas and off to the east, and the depression. Honestly, that's going to be Arthur before the weekend is through. And since we're kind of getting up there in time, we'll kind of leave it at that and leave some of the good stuff for tomorrow. But this climate issue, it's such a big to do, and it is a big to do, and we'll talk a little more about that tomorrow and how I became aware of what they tell us isn't necessarily what's really going on, how we can color a story with statistics when the statistics tell us one thing and the facts or unbiased statistics can tell us literally completely something different. So that's just something that we have done with weather. We do it with society. We can do it with all kinds of sciences. All right, guys. Scott Stevens here, and we'll do this once again tomorrow. Hey, everybody, keep looking up because who knows what you'll see.